A study of 5 students measured their time spent studying and the number of mistakes made on an exam. It found the following paired data. So for time spent studying, if a student studied 3 hours, their mistakes made during the exam would be 5. They made 5 mistakes. If they spent 5 hours studying, they made 3 mistakes. If they spent 1 hour studying, they made 7 mistakes, and so on. So we have 5 data points there, or rather 5 pairs of data points. Does there appear to be a linear relationship between time spent studying and the number of mistakes made? So I want to find the Pearson correlation coefficient to study the strength of the linear relationship. So our equation for the Pearson correlation coefficient is the number of data pairs times the sum of the products of the 2 data pairs minus the product of the sum. And then I divide this by a big square root. Inside the square root, you have a product of 2 things, and these 2 things are exactly the same, just with different variable names. You've got n times the sum of the x squareds minus the square of the summed x's, and n times the sum of the y squareds minus the square of the summed y's. So I look at this equation, and if I want to find this, I need the sum of x squareds, the sum of x's, the sum of y's, the sum of, oops, sorry, I think I misspoke. I need the sum of xy's, the sum of x's, the sum of y's, the sum of x squareds, and the sum of y squareds, right? I already have this one because that's just this guy squared. So I need all of these values, so let's build a table. This is my favorite way to do it. If I need the sums of the x's, then I'll build a table with my x's. So in correlation, it doesn't matter what you call x or y. So let's say that the time spent studying is the x's. So I've got 3, 5, 1, 4, and 2. And if I sum this up, I get 15. Right? This is the value of the sum of the x's. So I now know this part of the equation, the sums of the x's. Now I just need to do this for all of the sums that I need. So I need the sums of my y's. My y values are 5, 3, 7, 4, and 6. And if I add all those up, I get 25. So now I have the sums of my y's. All right, let's erase them as we go. So I've got the sums of the x's, I've got the sums of the y's. I now need the sums of the product x times y's. So here's my x times y. So 3 times 5 is 15. 5 times 3 is also 15. 1 times 7 is 7. 4 times 4 is 16. 2 times 6 is 12. And if I add up the product of x, y's, I get 65. So now we have dealt with that sum. And all that's missing is the sums of x squareds and the sum of y squareds. So let's give ourselves those. X squareds, y squareds. So x squareds would be 9, 25, 1, 16, and 4. Y squareds, 25, 9, 49, 16, 36. And if I add these up, my x squareds give me 55. My y squareds give me 135. So the reason I like this table so much is I can look at this table and just replace my equation. So this n here, let's get rid of what we've done. This n is the number of data pairs. So here you have 5 data pairs, right? You got 10 total data, but they're paired data. So you have 5 data pairs. So that's a 5 right there. And this sum xy is going to be replaced with the sum of xy's, 65. The sums of the x's right here is 15. The summed y's is 25. And we'll just keep going. We'll use our table to our advantage. So here we have 5 times the sum of the x squareds, which was 55, minus the square of the x's, which was 25. And I have 5 times the sum of the y squareds, which was 135, minus the square of the y's, which was 25. Oh, I'm sorry. That x squared should be 15. All right, 15. Okay, so as long as you do your order of operations correctly, you're going to find a correlation value of exactly -1. So actually, this data set has perfect negative correlation. So as your time spent studying increases, the mistakes made during the exam should decrease. And we have perfect negative correlation. So that almost never happens. Let's see what's happening. If I plotted this, time spent studying and number of mistakes. So the first data point that I have is if you spend 3 hours studying, you make 5 mistakes. So when x is equal to 3, you're going to make 5 mistakes. So I've got a point right there. The next point that I have, if you spend 5 hours studying, you make 3 mistakes. So if you 5 hours studying, 3 mistakes. If I do this for all of them, right, 1 mistake, or sorry, 1 hour of studying means 7 mistakes. So 1 hour of studying means 7. 4 hours of studying means 4 mistakes. And maybe you can see now that why we have a perfect negative correlation. 2 mistakes means 6 hours. Sorry, backwards. 2 hours of studying means 6 mistakes. So the reason we had perfect negative correlation is because all of these dots, I'm a bad artist, but they lie in a perfect straight line. So I could ask, what is the significance? So we're obviously going to be very significant here because we have perfect negative correlation. But what if you didn't get that? So for significance, we have to return to the Pearson correlation critical value sheet. So if you want to give yourself a 5% probability threshold, your R value needs to be 0.878. So here's an R value of 0. Here's minus 0.878. Here's positive 0.878. And of course, we can't be anything bigger than 1 or smaller than -1. And our R value, so here's the critical regions. If I was anything here or here, then I would be critical. So we are all the way down here at -1. So we are very critical. This is very strong negative correlation.